and the second video in the series on the normal distribution. In this video, we're going to look at some of the stuff under the hood. We're going to look at some mathematics. You're able to understand this mathematics. You may not be able to use it, but it's not necessary that you use this mathematics on a day-to-day basis. It's just necessary that you understand how we calculate probabilities for a normal distribution. So good to know, not used day to day. For a continuous random variable, we have a PDF, a probability density function. For the normal random variable, the PDF is f of x is equal to 1 upon sigma square root of 2 pi e to the minus 1/2 x minus mu over sigma, the last quantity squared, and that's the PDF. And it's a PDF that allows us to find probabilities. In the PDF, sigma is the standard deviation for the x random variable, and mu is the center or the mean for the random variable. Again, let's let the height of American males be represented by a random variable x. Then x is normal with a mean mu of 69.5 and a standard deviation sigma of 2.4. To calculate the probability that a randomly selected male would have height less than or equal to 72 inches, we would need to do the following. We would need to evaluate the integral of the PDF, the integral 1 upon sigma square root of 2 pi from negative infinity to 72 of e to the minus 1/2 x minus mu over sigma, that quantity squared, dx. And I know that many of you have already had a course in calculus, and though you may not want to evaluate that integral, you know what it is, and you know that that integral is the area under the curve. The PDF, if we would graph it, would be bell-shaped and look something like this. In the high point, we would have mu, the mean, 69.5 in this example. And if we wanted the probability of being less than or equal to 72, we need find the area under the curve, but to the left of 72. And that area would be the probability that x is less than or equal to 72. So to calculate probabilities, we use the PDF for the random variable, and it has a particular mean and standard deviation, and then we calculate areas under the PDF. Now, clearly we're not going to calculate those areas by evaluating that integral. Somebody else has done that for us, and we have got tables where we can look up those areas, or more conveniently, we've got calculators and computers that will calculate any area underneath the PDF for the normal distribution that we desire. So in the next video, we'll actually calculate some areas, but now you know what those areas mean. You know where they come from, and if you wanted to punish yourself, you could evaluate the integrals that are the definition of the areas.